Hello students, welcome to experiencetutor.com. Today we'll go through Electrostatics Part 3. Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th. And those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you. Question number 22. Describe different properties of charges. There are two types of charges, positive and negative. Second, like charges repel and unlike charges attract each other. Third, charge is a scalar quantity. Fourth, charge is additive in nature. Example, plus 2 column, plus 3 column, minus 3 column, plus is equal to plus 2 column. Fifth, charge is quantized. In other words, electric charge exists in discrete package rather than in continuous amount. It can be expressed in integral multiples. Fundamental electronic charge E is equal to 1.6 into 10 to the power minus 19 coulomb. Q is equal to plus minus Ne, where N is equal to 1, 2, 3 dot dot dot. Any natural number. Sixth, charge is conserved. In other words, the algebraic sum of positive and negative charges in associated in isolated system remains constant. For example, when a glass rod is rubbed with silk, negative charge appears on the silk and an equal amount of positive charge appeared in the glass rod. The net charge of the glass and silk system remains zero before and after rubbing. Question number 23. Describe the principle of superposition. Force on any charge due to a number of other charges is a vector sum of all the forces on that charge due to the other charges, taken one at a time. The individual forces are unaffected due to the presence of other charges. This is termed as the principle of superposition. To better understand the concept,
consider a system of three charges Q1, Q2 and Q3. The force on one charge, say Q1, due to other charge, say Q2 and Q3, can therefore be obtained by performing the vector addition of the forces due to each one of these charges. Thus, if the force on Q1 due to Q2 is denoted by F12, F12 is given by the following equation, even though other charges are present. F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 square, unit vector R12. In the same way, the force on Q1 due to Q2 denoted by F13. In the same way, the force on Q1 due to Q3 denoted by F13 is given by F13 is equal to 1 by 4 pi epsilon naught Q1 Q3 upon R13 square and to R unit vector 1 3. Thus, the total force F1 on Q1 due to the two charges Q2 and Q3 is given by F1 is equal to F12 plus F13 1 by 4 pi epsilon naught Q1 Q2 by R12 square unit vector R12 plus 1 by 4 pi epsilon naught Q1 Q3 by R13 square and to unit vector R13. The principle of superposition says that in a system of charges Q1, Q2, Qn, the force on Q1 due to Q2 is same as the given by Coulomb's law. That is, it is unaffected by the presence of other charges Q3, Q4, Qn. The total force F1 on the charge Q1 due to all the other charges is then given by the vector sum of forces F12, F13, F1n. F1 is equal to F12 plus F13 plus plus F1n is equal to 1 by 4 pi epsilon naught common bracket Q1 by Q2 Q1 Q2 upon R12 square unit vector 12 R12 plus Q1 Q3 upon R13 square unit vector R13 plus plus Q1 Qn upon R1n square R1n is equal to Q1 by epsilon Q is equal to Q1 by 4 pi epsilon naught sigma I is equal to 2 to n Qi R1I unit vector R1I upon R1I square. The vector sum is obtained as usual by the parallelogram law of addition of vectors. Question number 24. Consider three charges Q1, Q2, Q3 each equal to Q at the vertices of an equilateral triangle of side L. What is the force on a charge Q when the same sign with the same sign as small q placed at the centroid of the triangle shown in the figure? In the given equilateral triangle ABC of sides of length L, if we draw a perpendicular AD to the side BC, AD is equal to AC cos theta is equal to 3 by 2 L, and the distance AO of the centroid O from A is 2 by 3 AD is equal to 1 by 3 L. By symmetry, AO plus BO, AO is equal to BO is equal to CO. Thus, force F1 on Q due to the charge Q, small q, at A is equal to 3 by 4 pi epsilon naught capital Q, small q, upon L square along AO. Force F2 on capital Q due to the charge small q at B is equal to 3 by 4 pi epsilon naught capital Q into small q upon L square along BO. 4 pi force F3 on Q due to charge Q small q at C is equal to 3 by 4 pi epsilon naught capital Q into small q by L square along CO. The resultant of force F2 and F3 is 3 by 4 pi epsilon naught Q capital Q into small q upon L square along OA by the parallelogram law. Therefore, the total force on capital Q is equal to 3 by 4 pi epsilon naught capital Q into small q upon L square unit vector R minus unit vector R is equal to 0, where R is the unit vector along OA. It is clear also by symmetry that the three forces will sum to 0. Suppose that the resultant force was non-zero but in the same direction. Consider what would happen if the system was rotated through 60 degrees about O. Question 25. Consider the charges q, small q, and minus small q placed at the vertices of any equilateral triangle. What is the force on each charges? The forces acting on the charge q at A due to the charges q at B and minus q at C are F12 along BA and F13 along AC respectively. By the parallelogram law, the total force F1 on charge q at A is given by F1 is equal to F unit vector R1, where R1 is the unit vector along BC. The force of attraction or repulsion for each pair of charges has same magnitude. F is equal to q square upon 4 pi epsilon naught L square. The total force F2 on charge q is at B is thus F2 is equal to FR2, where R2 is the unit vector along AC. Similarly, the total force on charge minus q at C is F3 is equal to under root 3 Fn, where n is the unit vector along the direction bisecting the angle BCA. It is intersecting to see that the sum of the force of the three charges is 0, that is F1 plus F2 plus F3 is equal to 0. Question 26. Describe the term continuous charge distribution. Continuous charge distribution: any charge which covers a space with dimension much less than its distance away from an observation point can be considered a point charge. A system is closely spaced charges is said to form a continuous charge distribution. It is useful to consider the density of charge distribution as we do for the density of solid, liquid, and gas.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.